Hello students, welcome to my channel Concept Well. Today we are going to start with circle, part 1 of circle. So what is a circle? A circle is defined as the position of a point or points which are equidistant from a particular point, and the distance between them is called radius. So when we turn this particular line with this point fixed, we get a circle. This is called center of the circle and this is the radius of circle. Now the general equation of a curve ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. How to prove that this is a circle? For a circle, h should be 0 and a should be equal to b. So these are the points which make the second degree equation of a curve a circle. Now the radius of the circle, after putting h equal to 0 and suppose a equals to b equals to 1, if we make it, then x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the general equation of a circle. The center is given by minus g comma minus f. This is the center of the circle, and radius r is given by root under g square plus f square minus c. Okay. Also, for any second degree equation of a circle, delta equal to 0 is not equal to 0. Delta equal to 0 for pair of straight lines. Delta not equal to 0 for any other curve. Means ABC plus 2FGH minus AF square minus BG square minus CH square not equal to 0. Now, suppose we have been given to write the equation of a circle whose center is h comma k and radius is r. It will be x minus h whole square plus y minus k whole square equal to r square. Okay. Suppose we have been told to find the equation of circle passing through 3 points. Okay. So let the points be 0 comma 0 or 0 comma 0, a comma 0 and 0 comma b. We do what? We write the equation of circle x square plus y square plus 2gx plus 2fy plus c equal to 0, and we put the values. First putting 0 comma 0, we get c equal to 0. So c from this equation is gone. Now if we put a comma 0, it becomes a square plus 2ga plus 2ga equal to 0. So we get the value of g as minus a by 2. Similarly, putting 0 comma b, we get f equal to minus b by 2. So the required equation is x square plus y square minus ax minus by equal to 0. Similarly, you can find equation of circles from any three given points. Now, equation of circle passing through 2 points x1 comma y1 and x2 comma y2 and subtending an angle theta at the circumference. What is the meaning of it? A circle passes through 2 points. Okay, suppose this is A and this is B. Then it passes through A and B, and AB subtends an angle theta at the circumference of this circle. Now there can be two circles actually. If we see, a similar circle like this with the same angle theta subtended. So let us find the equation. The equation will be given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus this is equal to plus minus cot theta multiplied by y minus y1 into x minus x2 minus of x minus x1 into y minus y2. So if we put plus here, we get one circle, and minus here we get another circle. Okay, now suppose if these A and B were the extremities of diameter. Okay, means if A and B, AB is the diameter of the circle, then we know from class 10 syllabus that diameter always extends 90 degree at circumference. Then theta will be 90 degree, cot theta 0. So if A and B are extremities of diameter, then equation of circle comes out to be x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Okay. Now let us see what is the parametric equation of a circle. Now parametric equation will give us coordinates of any points on the circle. Suppose this is a circle with center h comma k. Okay, this line is parallel to x-axis. Okay, and at any point on the circumference, which when the radius of that point makes an angle theta with the line parallel to x-axis, then this line, if extended towards the x-axis, it will also subtend an angle theta. It may not pass through the origin, but it will always subtend an angle theta at this point, at any point where it cuts the x-axis. So the coordinates of that point becomes h plus r, which is the radius r cos theta, comma k plus r sin theta. So this is the parametric point. Or parametric form of a circle. Okay. So suppose h, and if the center of the circle is the origin, then what becomes? It is h becomes 0, k becomes 0. So it is r cos theta and r sin theta. Let us see what is the equation of a circle which has center at origin. It is x square plus y square equal to r square. This will help us in this will be taken as a general equation. Okay, if we have to find the equation of circle which has center at another point, we just put x minus something, means h whole square, plus y minus k whole square equal to r square. This was already told before, so it has came from this equation. Now let us see intercepts. What are intercepts has already been told in straight line chapter, but here the circle will also make intercepts. Intercepts means the length which has been cut on the axis. Suppose this is a circle, this is its center. Now suppose it has equation x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay, suppose this is the equation. Then suppose this is the x-axis, this is the y-axis, and it is AB and this is CD. So A is here, C is here. CD is the intercept on the y-axis and AB is the intercept on x-axis. AB is given by 2 root under g square minus c, and CD is given by 2 root under f square minus c. Okay. So these are the length of the intercepts. Now let us see the last topic of this video, position of a point with respect to a line, with respect to circle. So position of point with respect to circle. First let us grab the concept. This is the circle and it has center h comma minus g comma minus f. Okay, and we have been given a point, arbitrary point x1 comma y1. We have to find whether the point lies inside the circle or the point lies outside the circle. Okay, now there are two ways to do it, either conceptually or through a formula. Now what is the what is conceptually? You see that if we have derived the equation such that it has x minus k whole square, x minus h whole square plus y minus k whole square, like that. So we have the such that we have the coordinates of the center, or we already have minus g comma minus f. We take out the distance from these points. Suppose the point lies outside the circle. Okay, the distance will be greater than radius. So that will tell us that this point lies outside the circle. And if the distance, suppose the point is here, the distance is less than the radius, then it will tell us that this point lies inside the circle. Okay, and if the distance is equal to radius, then the point lies on the circle. And another method, that is, if we have been given the equation, which we always will have, x square plus y square plus 2gx plus 2fy plus c. This is the equation. We will put the coordinates on this equation. If I am denoting it by s equal to this. If s, after putting the coordinates, is greater than 0, it lies outside the circle. If s is equal to 0, it lies on the circle, and if s is less than 0, it lies inside the circle. Okay. Now, what is the maximum and minimum distance of a point from a circle? Okay. Suppose this is the circle. We have been given the equation and we have taken out the centers, which is minus g comma minus f. Okay. And we have been given a point, arbitrary point, which is x1 comma y1. Now, what is the maximum distance and minimum distance of this point from the circle? Maximum distance is if a point has been taken which is collinear with the center of the circle and this line and this point, and this point is on the further side, then the distance from this point to the given point will be the maximum distance. And the distance, if we take a point which is also collinear with the center and the given point, but it is on the nearer side, then the distance from this point to this point will give us the minimum distance of this point from the circle. So how to do it? First we have to take out the distance from this center to this point which is given to us. Okay, the distance, suppose it is d. Okay, so maximum distance, max distance becomes equal to d plus r, since this is d and this is r, and min distance becomes equal to d minus r, which is, suppose this is d, then if we take out the r, then what are we left with? The distance from the nearer point to the given point. Okay, this is the maximum and minimum distance of a point from the circle. So this video is over. I hope you liked it. Please consider subscribing so as to help me, and the next video will be the part 2 of the circle, in which we will show intersection of line and a circle with tangent, normals, etc. Thank you.